What are we going to be doing today? Um, we're going to be able to use the laws of detachment and the law of syllogisms to determine truth. How are we going to do this? We're going to apply the laws and then we're going to come up with a conclusion. And why are we going to do this? Because logical reasoning and determining objective truth is important. We're going to begin the process of showing why things are what they are. Using the things that we've built up, we're going to show why it is that things actually are true. This is called deductive reasoning. All right, so let's begin with our first thing, the law of detachment. Now, in a higher level class, they use the Latin versions of these phrases. If I remember correctly, the phrase that describes this in Latin is modus ponens. Not that you need to know that, but like here's a little tidbit of trivia for you. But we'll always refer to it as law of detachment here, just because A, that's what the book calls it, and B, it's in our native tongue. So we're gonna go with that one. But basically, here's how it works. If we're given an if-then statement, and then we're told that the hypothesis is true, then we can conclude that the conclusion is true. So basically, this is a structure for an argument. What we're saying is, if I wake up late, then I'm going to be late for school. I woke up late. Therefore, I'm late for school. So our when we're told to draw a conclusion, the conclusion that we're trying to draw is this thing right here. So our conclusion in the case I just described is therefore I am late for school. So just be aware these are our building blocks for our argument. And then right here, this last thing is our conclusion. It's what we're trying to show is true. All right? So we're going to be given building blocks. Our goal is to find that this thing that I'm given here matches with this thing that I'm given here. The way that I always describe it, and I feel like people get it when I talk about it like this, but we can try a bunch of different ways to describe it. But think of it like a key and a door, right? A given door requires a certain key to stick into the lock, turn the key, and then you can unlock the door, right? And then on the inside is whatever's inside the room. So here's our lock. This is our door. We're going to use P to unlock the door to go inside and find Q. All right. So that's the way I always think about it. And the key to making sure that you use this law correctly is making sure that whatever I'm told is true matches the hypothesis of the if-then statement. It has to. Otherwise, what we have doesn't work. I'm going to show you a couple examples of ones that do and do not work. So let's start with the ones that do work. So what I want to do is I want to start off by taking this and breaking it down into the model that we just had, right? P implies Q, P, therefore Q. So remember, the thing that follows our if is our hypothesis. If student gets an A on the final exam, so there's our P, then the conclusion follows then the student will pass the course. That's our Q. So we have P implies Q. If student gets A on final exam, then Q, student passes course. Well, What does this second sentence say? Felicia got an A on her history final exam. Well, is that in the form of P? Is that student gets A on final exam? Is Felicia's a student? She got an A on a final exam, right? So this is, it's more specific, right? If we're not just talking about in general a student, we're talking specifically about a student whose name is Felicia, and we're not sort of talking generally about a final exam. We're specifically talking about the history exam that she took, but this is still an example of a student getting an A on a final exam. So this here is of the form P, right? Well, here's one thing, here's the other. It matches our form, right? P implies Q, P. So what can we conclude? Therefore, yeah, exactly. Exactly right. That's exactly it. She will pass history. So this is what I'm doing, what I'm drawing out. I'm drawing out all these diagrams and stuff. This is a lot to do, and it may or may not be necessary for you. You may be able to sort of follow the pattern in your mind and look at it and go, "Oh yeah, I get it. I see that this is what's happening. I can draw the conclusion." But I'll tell you, sometimes maybe the way that it's all written is going to be a little bit more difficult to look at, and that's okay. But if you know enough to be able to draw this out, it'll be a lot easier for you. So again, you see here's your P implies Q. You see that they're giving you a P. So that means that you are allowed to produce Q. Student, in this case Felicia, will pass the course, in this case history. So our conclusion can be right. So go ahead and give it a try on your own. I'm going to put like 2 minutes up on the clock for you. Um, Make sure that you are capable of drawing a conclusion here. I want you to, in the comments, talk through what a conclusion would be. Now, it doesn't have to be exactly the same as everybody else, but everyone should come up with something pretty similar for their conclusion. So we're given an if then statement. That's important. So we know we've got our P implies Q. Now the question we have to ask ourselves is this thing that they gave us in the form of P? Are we being told that a ray divides an angle into two congruent angles? What are we being told? Ray RS divides angle ARB so that angle ARS is congruent to angle SRB. Is that what this says? If a ray divides an angle into two congruent angles. So is this ray dividing an angle into two congruent angles? Absolutely. So we've got our second statement is our P statement again, right? So what can we conclude? Therefore, Q. And I do these three little dots here. This is a symbol that means therefore. And so, like, for example, if you're doing a quiz and you wanted to say you didn't want to write out the word therefore, you could do these three dots in a triangle like that. That's what that means. So therefore, what is ray RS? The ray is an angle bisector, right? So our conclusion is or therefore. So as far as I'm concerned, your final answer can look like this, or you can dispense with the word therefore. As long as what you're telling me is that ray RS is an angle bisector because of what we set up here somehow, you know you're okay. So now let's look at situations where it doesn't work. So look, if let's label our P, let's label our Q, and then we look at our statement down here. So we have our P implies Q. We have our if P then Q. But what is this part down here? Angle 1 and angle 2 share a common vertex. Is sharing a common vertex a P thing or is it a Q thing? Well, where do we see common vertex, right? It's up in the Q. Well, that's not what we're supposed to have. What we're supposed to have is this, right? P implies Q, Q, therefore, P implies Q, P, therefore Q, right? That's what we want. We don't have that. We have P implies Q, Q. That's not what we had. So can we do anything? There's nothing to conclude because we don't have an argument written in the form that we like it. If we don't have it written in the form of the law of detachment, we don't have anything. This is not what we're used to. This is not what we're supposed to have. We don't have anything to say because we don't have these first two. This one matches, but we don't have the right key for the lock we need. You get what I'm saying? We have the key that opens up the Q door, but we need the key that opens up the P door. And we don't have it. So this right here, this is a bad argument. For any of you who end up taking debate or something like that, the name for an argument like this, especially if you try to draw any conclusions from it, is called begging the question. That is to say, you are presuming the answer. You're presuming the answer before you even have the question shown it to be true. So this is what I've circled here in red. This one, P implies Q. Q, that's a bad argument. You don't have anything that you can conclude there. So be careful. Be careful. So take a look at this one, look at it, see if you can understand why it's not true. All right, so let's make our labels again, just like we have been. If what? If a figure is a square. So this is our P. Then what? Its sides have equal length. That's our Q. So we've got our P implies Q. What we need to find is we need to find P if it's there. And if it's not there, we need to know that it's not there. So Q is about having equal length. P is about being a square. Figure A, B, C, D has sides of equal length. Well, that's a Q statement, right? Equal length is about Q. So once again, do we have remember what we want is P implies Q, and then we want to be able to say P. That way we can therefore say that Q is true. But look what we have. We've got P implies Q, and then we're given this Q. We don't want that. So the thing of it is, the only conclusion that we draw is that we can't draw a conclusion. We're not allowed to. This argument is a bad argument, right? Once again, this is a bad argument. We don't have the right building blocks to make a good argument, so this is a bad argument. So now let's talk about our other possibility for making new and important things. So here, what we call this is called the Law of Syllogism. Remember, we talked before about what a syllogism is, just an if-then statement. So this is just the law of combining if-then statements. I don't know that this one has a Latin name for it. It probably does. When I was in my logic class, we just what did we call this? Like indirect arguments, I think, is what we called these indirect arguments. We would have to go through and say, all right, with all this information, I want to prove that P implies R. So I'm going to start with P and I'm going to show R, so I can indirectly show that P implies R is true. But we can call this the law of syllogism. That's what the book says. You don't even have to name check this. I'm not going to look for you to remember what this thing is called. All I need you to know is that this is the thing that does this thing here, right? And what I want you to be able to do is I want you to be able to think about this like you're stacking train cars. Think about you've got a bunch of train cars in a line and you're trying to show that they're all connected to each other. Here I'm saying P implies Q, but we also know that Q implies R. So what we're really doing in our minds is we're connecting all of these together because we can. P goes to Q, Q goes to R. We can connect them all. And then we're just cutting out the middleman, going straight from P to R, bypassing Q completely because we don't need it anymore. All right. So look at this example that they give. If it's July, then you're on summer vacation. If you're on summer vacation, then you work at a smoothie shop. Now, no one is saying that A, it's July. No one is saying that B, you're on summer vacation. And no one is saying that C, you work at a smoothie shop. No one is saying any of those things. But what we are saying is that the statement, the implication itself is true. That if it were July, then you would be on summer vacation. If you were on summer vacation, then you would be working at a smoothie shop. So what we're doing is these are slightly more abstract arguments, right? These are not necessarily going to be like concrete. So basically, again, think of this like a key in a lock. You want to make sure that this one and this one match. That way you can skip the then on this one, skip the if on this one, and then just connect the other two. All right? So let's look at some examples here. If a figure is a square, then the figure is a rectangle. If a figure is a rectangle, then the figure has four sides. So let's look at the structure, right? A figure is a square, we're going to call that P. The figure is a rectangle, we'll call that Q. Well, now look, A figure is a rectangle. That's the same thing as the one above. So we're going to repeat Q because we can, because they're the same. Then the figure has 4 sides. Well, we need a new letter because this is different, right? Let's call that R maybe. So here we have P implies Q, and Q implies R. Well, that's the format we want, right? This is the Q's combined. This is, right? So therefore we can say P implies R. That is, we can say if a figure is a square, then it has 4 sides. And I really do recommend putting the word therefore before your stuff. Because by saying therefore, you are directly telling me, hey, my conclusion is that, and then you say your thing. So therefore is a really great way to say your conclusion that you have, starting with therefore. All right? Go ahead and give this one a try. If a whole number ends in 0, then it's divisible by 10. If a whole number is divisible by 10, then it's divisible by 5. What is my conclusion? Okay, so let's go over it. So again, a whole number ends in 0. That's going to be our P. It is divisible by 10. That'll be our Q. So now let's look in the second one. Let's see. A whole number is divisible by 10. So that's a Q statement, right? Being divisible by 10 is about what we're talking about for Q. And then it is divisible by 5. That can be our R, because that's a new thing. So do we have a chain of information? P, Q, R? Yeah, we sure do, right? If P implies Q, and if Q implies R, then we can cut out the middleman, go straight to P implies R, and we can say if a whole number ends in 0, then it's divisible by 5. And put a therefore out in front. And there we go. That's how we know. Try this one out. If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. So let's label everything out. You do gymnastics. That's a P. You are flexible. That's a Q. You do ballet. That's not a repeat of you do gymnastics or you are flexible, so we have to call this one R. You are flexible. Well, that's a repeat of this one, which we named Q. So what we have here is P implies Q and R implies Q. Can I connect these two with, do they have the same letter? There's no connection here, right? There's no connection, so there's no conclusion. We'll get there eventually. L, there we go. U, S-I-O-N. There's no connection, so there's no conclusion. This is a bad argument. If you're trying to make an argument anyway, this is a bad argument to try and connect something from because there's no connection possible. If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. Great. Okay. There's nothing more that you can say though. Okay. So give this next one a try. See if you can figure out why it's a bad situation here, why we cannot connect anything from it. Okay. Let's talk this one through. Again, we're going to label. These two rays are opposite rays. That'll be our P. Then these two rays form a straight angle. That'll be our Q. Two rays are opposite rays. That's a P statement, right? Two rays are opposite rays. Two rays form a straight angle. That's our Q statement. These are both the same. I mean, this one is slightly more specific, but like even then, it's the same thing. Is there any new conclusion that we can draw? No. Since we don't have P implies Q and Q implies R, since we don't have that, we just can't draw a conclusion. It's as simple as that. There's no conclusion to draw. So, there's nothing that we can do. I mean, these two are basically repeats of each other. Okay. Now here we're being given three statements. So what we're going to do in this one is we're actually going to take our law of detachment, our law of syllogism, we're going to combine them. So look what we have here. You live in Accra. That'll be our P. Accra is, well, you'll see. You live in Ghana. That'll be our Q. You live in Ghana. Okay, that's a repeat. Good. That's a repeat of Q. You live in Africa. Well, that's a new statement. We'll call that R. And then Aisa lives in Accra. Well, that's a P statement. So let's look at what we have here. We've got P implies Q, right? If P, then Q. We've got Q implies R. That's if Q, then R. And then our last statement is just P, right? So there's not necessarily one correct way to do this, but here I'll go in order based on what we have. Look, we've got P implies Q. We've got Q implies R. Well, this is law of syllogisms, right? So we can take this and we can rewrite it as P implies R, right? And then we'll bring this unused thing down here. Well, P implies R. P. Do we have a key that goes in the right lock? Yeah, we do. So therefore, we can finally say that R. So now that we know, we can conclude R. Well, what is R? You live in Africa. Who lives in Africa? Who are we talking about this whole time? Is Aisa, right? So our conclusion can be, therefore, Aisa lives in Africa. Now, there's a lot of different conclusions that you can actually draw here. What I always used to say is there's like many. We drew a conclusion here using the law of syllogisms. We already drew the conclusion that if you live in Accra, then you must live in Africa. That is a conclusion. You could even skip this middle one and say, since if you live in Accra, then you live in Ghana, and Aisa lives in Accra, you could also conclude that Aisa lives in Ghana. That's fine. But if we want to take everything to like its very end, this is the sort of the final, the most last thing that you could come up with. It's up to you. Okay. Next one. This one is for you. If a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. The Nile is 4,132 miles long. What conclusion can we draw? Think about this. Okay, let's talk about this. So, a river is more than 4,000 miles long. That'll be our P statement, right? It is longer than the Amazon will be our Q statement. Now let's look at our next sentence. A river is longer, well, that's the same thing again, right? A river is longer than the Amazon is still a Q statement. It is the longest river in the world. That's a new statement, so we'll call it R. Now let's identify the Nile is 4,132 miles long. Well, let's look. Okay, doesn't say anything about being the longest river in the world. Doesn't say about being longer than the Amazon. A river is more than 4,000 miles long. Is this more than 4,000 miles? Yeah, of course it is. 4,132 is more than 4,000 miles, right? So we know that this is a P statement, right? So now let's do that. Let's put all that together. We've got a P implies Q. We've got a Q implies R. And we've got a P. What does this tell us? Well, once again, from the previous one we did, we can take the time to write it out. We can say, all right, well, here's using the law of syllogism, we can combine these. And then this is the law of detachment, since these are the same. So what we can conclude here is R. Therefore, the Nile is the longest river in the world.